Hello everyone and thank you for watching this video lecture. In the previous lecture, we learned about lists in Python. Today, we want to study tuples in Python. A tuple simply is an immutable and ordered collection of items in Python. Unlike list, once a tuple has been created, its elements cannot be changed. No adding, no removing, or modifying. Lists are mutable. It means you can change their contents after creation. You can add, remove, or modify elements as you have seen in the previous lecture. However, tuples are immutable. It means once they have been created, their contents cannot be changed. Another difference is lists are made using square brackets. However, tuples are made using parentheses. But in some cases, parentheses are also optional. Tuples are generally faster than lists because they are immutables, allowing Python to optimize their handling. Lists are slightly slower due to overhead of supporting mutability. Lists are ideal when you need a collection that might change, like dynamic to-do list. Tuples are great for fixed collection like coordinates x and y, or when you want to ensure data integrity as dictionary keys, since tuples are hashable if their contents are immutable. Lists have more built-in methods like append, remove, pop because they are mutable. Tuples have fewer methods, mainly count, index, something like that. In short, use lists for flexibility and tuples for fixed and unchangeable data. Let's start coding with tuples. For example, we want to create an empty tuple. Simply we can say t1 is equal to parentheses, right? And if you print this t1, then you will see just an empty tuple. And if I want to get type of t1, then it shows it's a tuple. Or we can create tuples with an integers, like for example, t1 is equal to 1, 2, 3, 4. And if I print t1, I can get tuples 1, 2, 3, 4. Or we can create tuples with mixed data types. For example, t2 is equal to 1, Python, then I can say 2.5 and also true. So you can see here, this T2 is a tuple with different data type, integer, string, float, and Boolean. And also we can create a single item tuple. We should take care of comma. So if you want to get T3 is equal to, for example, 4 and comma, right? Then we can print T3, right? This single item tuple requires a trailing comma that we can see here. We put it here. So if I use the comma, you can see type of T3 is tuple. But if I remove this comma, it is 4 and type is simply integer. So if you want to be a tuple, so you should use this comma to have tuple. Tuples support indexing and slicing just like lists. Indexing starts at 0 and negative indices count from the end like lists. For example, we have T4 is equal to A, B, C, and D. Then I can access the elements by an index, right? For example, I can say T4, 1, it is B. Like T4, 0, it is A. T4, 4, it is out of range because 0, 1, 2, 3. The last one is 3. Or if I go for T4 minus 1, it will give me the last one. Also, the same thing as list, we can go for a slicing like T4, and here I can say 1, 2, 3. So you can see, give me B and C. And in here, if I say up to 2, it will give me A and B. And if I say 2 onward, it will give me C and D. So here is slicing. So in slicing, we have stop and start, right? So when we say T4, 1, 2, 3, it means start from 1 and stop at 3. 3 is not included. Tuples are immutable. It means you cannot modify their elements after creation. For example, I have T5 is equal to like red, then blue, then green, right? This is my T5. Let me try to change a number 0, right? So I say T5 index 0 is equal to yellow, right? So if there is one error and says tuple object does not support item assignments. Next, we go for tuple operations. Tuples support concatenation, repetition, and membership setting. For example, we have T6 is equal to 1, 2, and 3, and T7 is equal to 4, 5, and 6. Right? These two tuples. I want to go for concatenation. So then I can go for concatenation T6 plus T7. So you can see 1, 2, 3, 4, 5, and 6. Then for repetition, for example, I say T6 multiply 3, right? It will be repeated 3 times. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Or I can go for membership testing, whether it's there or not. So what is T6? T6 is 1, 2, 3. 2 in T6, it say yes, true. I say 7 in T6, it say false because it is not there. Tuples have only 2 built-in methods, count and index. For example, we have T like 8 is equal to 1, 2, 3, 4, 5, 6, and 7. So now I want to count the elements in this one. So I can say, for example, let me add some repetitive here, 6, 6, 5, right? Then I say T8 dot count 2. How many? 1, 2 is there. How many 5 is there? 2. How many 6 are there? 3, right? This is for counting. Next, find index of an element. I can say T8 dot index of, for example, 4, right? It's a 3, so 0, 1, 2, 3, right? If I say 5, 4, it will give me the first one. If I say 6, then it will give me the 5. We can also define nested tuples. Tuples can contain other tuples as well, allowing for complex data structures. For example, I say T9 is equal to 1, then another tuple inside, for example, 1 and 2. Then in here I say 3, 4, 5, and in here I say 6 and 7, right? This is a nested tuple, right? Then, so I can print it like T9. You can see here, this is a nested tuple. I want to access, for example, T1, right? T9, 1. So it will be 1 and 2, right? And if I say T9, 2, T9, 2, it will be give me 3, 4, 5, 6. If I want to access this one, right, I should write here T9, 0, right? It will give me 1, right? But which one it is? So let's change this one to 3, and let's change this one to 2, 3, right? So what is T9? It is 1. If I say 1 and 0, so it should give me 2, right? So you can see it is 2. So if I have 1, 2, so this is 1, 0. What is 1, 1? 1, 1 is this one, number 3, right? So what is this one? This is 0, 1, 2, 3, 3, 0. So 3 and 0 should be 6. Tuples support packing. It means creating a tuple and unpacking, assigning tuple elements to variables. For example, we have T10 is equal to 1, 2, 3, right? So for packing, parentheses are optional, right? So in here, if I print T10, it will give me 1, 2, and 3. And if I say type of T10, it is a tuple, right? So this is for packing, okay? Then if I want to go for unpacking, I can assign tuple elements to variables. For example, A, B, and C is equal to T10, right? It means A is equal to 1, B is equal to 2, and C is equal to 3. So what is the value of A? 1. What is the value of B? 2. And what is the value of C? 3, right? In this way, we can unpack. Also, we can unpack with multiple variables. For example, we have X and this star Y. This star Y collects remaining elements into a list. So the first one will go to X, the remaining go to this star Y. So if I say here, for example, 1, 2, 3, 4, 5, in this case, X is 1 and the remaining is Y. So 2, 3, 4, 5 as a list. So this will be assigned to Y as a list. Tuples are often used to return multiple values from functions. For example, we want to define a function returning a tuple. We say, for example, def f1 is equal to number, def f1 and receive numbers. Then in here we say minimum is equal to mean of numbers, right? Mean of numbers, and maximum is equal to max of numbers, and average is equal to sum of numbers divided by length of numbers. Then it will return minimum, maximum, and average. Then I can call function and unpack results. So for example, S is equal to F1, and as the numbers, I will send this one 1, 2, 3, 4, 5, right? So here, then I can unpack the return values. So I can say here, mean value and max value and average value, these are equal to S. It means output of the function, right? So now I can print mean value, it is 1. I can print max value, it is 5, and I can get average value, which is 3, right? In this way, we can unpack. Tuples are more memory efficient and faster compared to lists due to their immutability. So for example, we want to compare tuples and lists. So in here, we import this. So we define a tuple and list with the same elements. So for example, T13 is equal to 1, 1, 2, 3, 4, and 5. And L1 is equal to 1, 2, 3, 4, 5, right? With the same values. Now we want to compare memory usage. So we can say T13 size is equal to sys dot get size of T30. This gets size of tuples in bytes, right? And we do the same for L1s is equal to sys dot get size of L1. Now we can print. So print if tuple size is T13s, and the same for the list size. List size is L1s, right? So let's see. Tuple size is only 80, but list size is 104. So tuples are lighter. Okay, that's all. This was an introduction about tuples in Python. Tuples are versatile and lightweight data structure in Python. We can use them when we need an immutable sequence, when we want to return multiple values from a function, or when memory efficiency and performance are priorities. Please experiment with the examples that I provided for you to deepen your understanding, and also please feel free to send me your questions by leaving a comment below this video. Thank you and see you in the next lectures.